All right, last lecture for bones of 2020. Here we go. So lower limbs, 8.3. We are looking at weight bearing as our primary function for these bones, and obviously are going to be involved in movement as well. So you can see on this slide the list of bones that we'll be looking at. Your upper leg or thigh is made of your femur, longest, strongest bone in the body. You have a kneecap called a patella. It's one of those sesamoid bones located in that very complex knee joint. Your leg consists of a tibia and a fibula, so much like your forearm has that combination ulna radius, as does your leg. Similar in structure, sort of, and connected again by that interosseous membrane. And then you have the foot. So within the foot, you've got tarsal bones, which are like your wrist bones. So those are ankle bones, like your carpals. Metatarsals, just like the metacarpals for your palm, you're going to have metatarsals for the sole of your foot, and then phalanges or digits for the 5 toes. So let's get rolling here. The first, as I mentioned, longest, heaviest, strongest bone in your body is the femur. Challenging to break, but not impossible. My boyfriend's mother shattered it in about 6 places last year, crazy as that is. And then one of my students, my first year teaching, was a cheerleader, and they missed her on the catch when they threw her. She shattered her femur too. So that's a long recovery process for a bone like the femur to heal. So taking a look at our femur, very long bone, usually gives a good idea to forensic pathologists, anthropologists for height of a person. In terms of telling right and left, the head, which is this ball portion of the femur, should be medially facing, as should what's referred to as the patellar surface. And that is this piece right here. That is where this bone, the patella, your kneecap, sits and gets locked in by the various ligaments and tendons that make up the knee joint as well. Okay. All right. So in terms of markings that you need to be able to identify on the femur, obviously the head for sure. This is referred to as the neck. I'm not requiring it, but it's not terrible to know. And then you have these 2 kind of crests or bumps. All right. You can definitely see them both from the anterior side, but the posterior side gives you a bit of a better view. And so you have what's referred to as the greater trochanter, and that is this kind of crest bump-like portion. And then on the bottom, you have the lesser trochanter. Much like the tubercles on the humerus, you have essentially muscular attachment and ligament attachment points in these very large projections that are located on the proximal end of our femur. Okay. Also on that posterior side, you have this kind of ridge that runs down the femur, and you can see that pictured here. That's called the linea aspera. Again, another location for muscle attachment, especially for glutes and muscles of the thigh and the leg. Okay. All right, then we reach the distal end. So that's your proximal end, head, greater and lesser trochanters, which again, you can see from the anterior side as well. Posterior side, linea aspera, so that ridge, all right, that's created there on the posterior side. And then we get down to the distal end. All right, on the distal end, you have that patellar surface, which is that smooth anterior surface on which the patella is going to sit. Oops, upside down. All right, where that patella is going to sit. And then you have condyles and epicondyles, so much like the humerus did. So medial side, remember, is where the femur's head is located. So that means this would be the medial epicondyle, and this would be the medial, the lateral epicondyle. So epicondyles are on the sides, condyles are on the concave surfaces. So you have medial epicondyle and you have lateral epicondyle. And again, you can see those here, medial and lateral. Again, medial is on the head side. You have this kind of flare bump that's called the adductor tubercle for your adductor muscles to attach to, and the medial epicondyle is just distal to that. The smooth surfaces, medial and lateral, are the 2 condyles, and they are going to articulate with the proximal end of the tibia, forming your knee. All right. Your knee doesn't have that nice hook like the ulna had to attach to the olecranon fossa of the humerus. So it's not like your elbow in that way, but it is a modified hinge. so that it has the idea of a hinge using these condyle surfaces, these smooth surfaces to articulate. All right, so medial on the head side, lateral obviously on the opposite side. Last but not least, on the femur, you have this fossa here, this depression located between your two condyles, and that is referred to as the intercondylar fossa. So inter meaning between, condylar between the condyles, and then fossa because it is a depression, right? So those are all of your femur markings. So a quick recap: head, neck, greater and lesser trochanters, posterior side round, remember, linea aspera. Flip that, that was your proximal end, and remember medial on the head side, so go down to the distal end. You have the adductor tubercle. Below that is the medial epicondyle, opposite side lateral epicondyle. And then you have the two condyles, medial and lateral. And then you have the intercondylar fossa. The patellar surface sits on the anterior side, and that is where this bone, your patella, sits. Right? So that is your femur and your kneecap. Then we make our way to the leg. So you have two bones there, a very large, thick shin bone, anatomically referred to as the tibia, and then a very thin, all right, a very, very thin secondary bone called the fibula, all right? So between these two bones, essentially we have another combination of our two forearm bones. So similar to our radius and our ulna and our forearm, you have this combination. So you can see this interosseous membrane again, holding them together. Not the same type of movement that we see with our radius and ulna. Obviously, the fibula doesn't have that nice golf tee circular head, allowing for that pivoting or spinning to do that pronation, supination, right, that turning over. Basically, what you have here is a large weight-bearing bone. Obviously, that's the tibia. And then you have this skinny, almost accessory bone next to it called the fibula. I'm going to do the fibula first because there's only two markings that you need to know on that. So fibula being the skinny lateral bone, it has a head that is going to articulate with the tibia, and you'll see on the tibia there's a nice smooth articulating surface for that. And then it has the lateral malleolus, all right, the lateral malleolus, and that is this kind of putty-like piece that sits on the distal end. So proximal end is the head of the fibula, distal end is the lateral malleolus of the fibula. Then you have the shin bone or the tibia, which is the weight-bearing bone. So weight-bearing bone, not a weight-bearing bone. And on your tibia, we have a couple of notable structures here, all right? On the proximal end, you have the two condyles. So in order to figure out medial versus lateral, you need to look at the distal end of the tibia. And you'll see that it has this kind of putty-like structure that oozes out, and that is the medial malleolus. All right, so if you feel kind of down where your ankle is, you can feel the medial malleolus articulating with the tarsal bones, and that lets you know your medial side. So if I know my medial side, then I know that this is my medial condyle, and that would make this my lateral condyle. In between my two condyles, I have these two kind of almost pointy looking teeth, and that is referred to as the intercondylar eminence. So kind of like your eminence, your highness, wearing a pointy crown with jewels. That's how I remember the intercondylar eminence located here. Again, important for tendon and ligament attachments, all right? So medial malleolus on the distal end, medial condyle, lateral condyle, and then in between those, you have the intercondylar eminence. You also have this bump on the anterior proximal surface of the tibia, and that is referred to as your tibial tuberosity. And lastly, you have this ridge that runs down your tibia, and that's referred to as the anterior border. Right? Again, all of these markings notable for muscle and ligament attachment, especially in the leg. Perfect. All right, that is everybody. So quick recap: weight-bearing femur, weight-bearing tibia, non-weight-bearing fibula. Proximal end has the head of the fibula. Distal end has the lateral malleolus of the fibula. Tibia or shin bone, medial side has the medial malleolus, right? This kind of hanging down putty on the distal end. That makes this your medial condyle, this your lateral. In between, you have the intercondylar eminence, tibial tuberosity on the anterior side, and then the anterior border that runs down here, okay? Last but not least, you have the foot. So again, much like the hand, we are going to have a similar setup in terms of tarsal bones, metatarsals, and phalanges, just like we had carpals, metacarpals, and phalanges in our fingers. Again, we'll be able to see those weight-bearing bones. So you have the talus and the calcaneus. So these very large bones of the ankle are what are going to transmit that weight from femur to tibia to talus to calcaneus and transmit that down. Obviously, we're only going to put them on very large bones, all right? Your calcaneus, this very large bone here, your heel bone, is what your Achilles tendon or your calcaneal tendon is going to attach to. I'm sure you've heard of the Achilles. Very important tendon that connects your calf muscle, your gastrocnemius, to your heel and allows you to walk. Okay. And then the various other bones of the foot. So let's take a quick peek. We are both looking at the right foot, both on the one I have as well as the one that's pictured. So in terms of bones of the foot, again, you have that very large heel bone. That's your calcaneus. The articulating bone that articulates with your tibia, just like this, to allow you to walk, is your talus. So talus with the tibia. All right. Then on the medial side, you have a bone called the navicular bone. And on the lateral side, you have one called the cuboid. And then you have three smaller cuneiform bones. All right, three smaller cuneiform bones. So starting on the medial side, you have the medial cuneiform, the intermediate, and the lateral. All right, Mick, Ick, and LC navigate the cube with Tal and Cal. So that's my thing that I tend to do. I start with the cuneiform bones. So I go to my metatarsals and I start with the first medial cuneiform. Mick, Ick, and LC navigate the cube with Tal and Cal. And again, my pattern is always going back to the large digit, the number one digit side, just like I did with the bones of the wrist. I always started on my thumb side and started back every row. I do the same with my hallux or my big toe side. So medial, intermediate, lateral cuneiforms, navicular and cuboid, talus, and calcaneus. Again, come up with your own, whatever it takes. Mick, Ick, and LC navigate the cube with Tal and Cal. That's my thing that I do. All right. So those are your ankle bones, your tarsals. Then you have 5 metatarsals. So just like your hand, the sole of your foot is made up of 5 metatarsals. You'll notice that metatarsal 1 is expanded in a couple ways. And that's because it's going to create that ball of your foot to join with the hallux or the big toe. Needs to be modified to create some arches. All of these metatarsals actually are modified to create arches in your foot. And again, those modifications allow for us to be bipedal, meaning that we can stand on 2 legs and we can walk upright. Right? So metatarsals, again, are numbered 1 through 5. So metatarsal 1, 2, 3, 4, and 5, if you were identifying it anatomically. And I'll flip this. And then we have our toes, okay, our phalanges or our digits. So again, just like our thumb, our hallux or big toe, great toe, only has a proximal and a distal phalange. And then you'll notice digits 2 through 4 all have 3. They have a proximal, a middle, and a distal phalange. And that, again, is numbered. So third digit, third phalange. So you have the third proximal phalange. You have the third distal phalange. You have the 5th middle phalange or phalanx, etc. So priorities with the foot is making sure that you come up with something to remember these ankle bones, and then obviously numerically for your metatarsals and your phalanges. There's several different views here of your foot. Giving you the lateral view can kind of give you an idea of how those arches are going to work. You can see your calcaneus and your cuboid as well as metatarsal 5 and the other 4 kind of arched up to create these arches of your feet. And again, that helps with our ability to be bipedal and to walk, right? Last but not least, as we've gone through all of these bones, hopefully you are remembering that there's always going to be some variation in those bone structures. They are highly influenced by hormones. So males and females are going to have slightly different bone structures. And even within those 2 groupings, you're still going to have variation within. I mentioned earlier, anthropologists or forensic pathologists can identify lots of things, as you can see listed here, from bones. So that's why skeletons are really interesting to find, especially for older humans, like ancestral humans, because they can allow us to get an insight into what our early ancestors look like. What was their body size, muscle mass and things like that. Some type of medical history, so your teeth, obviously any type of fractures or potential surgeries that were done can be seen in the bone tissue. Age and sex, again, based on those measurements, where bones have fused, when they fused, etc., can all give us an idea of a person's sex as well as their age. And then again, tying into muscle strength and mass, body size, based again on the length and size of each of those bones. So that wraps us up with appendicular skeleton. Happy studying.